Hey guys, Mrs. Polson here. We're on Unit 2, Segment 1. Unit 2 is called Biochemistry, so the chemistry of life. And there are 3 segments in this unit. You will be taking notes on lined paper just like before. And the first segment is going to be a chemistry review. So total review. We're going to fly through Segment 1. Segment 2 is macromolecules. And segment 3 is enzymes. The objectives for this unit are describing the composition of the 4 major organic molecules, explaining the structure and function of the major organic molecules that compose living things. We're going to describe how dehydration and hydrolysis relate to organic molecules. And you should also recognize and explain that macromolecules such as lipids contain high energy bonds. You explain the role of enzymes and other proteins in biochemical functions. I forgot to mention that you don't have to write these down, but these are the objectives for the unit so you know where you're going with your learning. You don't have to write these down at either, but these are your main vocabulary words. If you were so inclined to make flashcards or sort cards, I would use these words to help you learn. So element, isotope, compound, proton, neutron, electron, nucleus, ionic bond, covalent bond, reactant, and product. Okay, for segment 1, we're going to start with subatomic particles. Segment 1, by the way, is atoms, molecules, compounds, and bonds. And it's a complete review. So here are some vocabulary words. Subatomic particles mean sub means smaller than, atomic means atom. So smaller than the atom particles. These are the things that make up an atom. So we have a proton, which is positively charged, proton positive, both P's. Neutron is a neutral particle, has no charge, and that's how you can remember it's neutral as a neutron. And electrons are negative particles. The nucleus contains the protons and the neutrons, and the addition, like adding these up, the mass is your atomic mass, is your mass number. So the nucleus houses the protons and the neutrons, and the electrons are orbiting around that space. You need to know that. Elements are the periodic table of elements I want you to think about, and it's one type of atom. So when we say type of, it has a specific number of protons. That's what we mean when we say the element, one type of atom, a specific number of protons. An isotope is mentioned in your reading, and it talks about how some atoms can actually gain or lose neutrons. So even though they have the same number of protons, they become isotopes if they gain or lose neutrons. And you can see an example here. This is a hydrogen atom, has 1 proton, has 1 electron, and this particular one doesn't have any neutrons. If it gains a neutron, which is the gray color, it's now deuterium, and it's a form of hydrogen. And here's tritium, and it just has 2 neutrons. Still only has 1 proton, though. We call all of these isotopes, isotopes of hydrogen. So that's an example. A compound is a chemical combination of 2 or more elements. So H2O, here's your H2O, okay? And here is NaCl. So it looks like we have a combination of, here's 2 elements. Here's 2 elements, but we have 2 hydrogen and 1 oxygen. Here's H2O. And this is your table salt, and this is your water. So these are just examples. There's CO2. There's a lot of other examples, obviously, of chemical compounds. You are going to be responsible for knowing about the 2 types. There are 2 types of bonds that can occur, ionic bonds and covalent bonds. If you remember from chemistry, the difference between the 2. Ionic has the word ion in it, so ions are formed when electrons pop off or join in. So I have an example here. You have a sodium atom. It has 1 electron in its outer orbital shell. It pops off, and then you have chlorine here that wants a partner for its electron right here, and so it's going to snatch up this one that sodium is losing. It's going to snatch it up. Well, now they have a charge. This is what happens. When the sodium loses the electron, it now has more protons in its nucleus that's not shown right there. So now it has a positive, it has one more proton than it has electrons. And so therefore it's a positive 1 charge, and we write the symbol like that if you remember from chemistry. So now it's charged. That means that there's an attraction happening because of the charge. Here there wasn't so much. And here's chlorine with the gained electron. Because it's a negative electron that it gained, it now has an extra negative charge to it, just 1, because it only gained 1 negative charge. So now they're oppositely charged and they're super attracted. Opposites attract. So these are now ions that are attracted, and it's a strong bond because of that, and it's called an ionic bond. If you're in an area where you can actually speak, nobody's around you, I would say it, ionic bond. Ions are formed, attraction happens. This is when the electron pops off and rejoins on another atom. Covalent bonds, if you remember from chemistry, are when sharing is caring. So instead of popping off an electron, they're actually going to share their electrons. So hydrogen has 1 electron, and then oxygen has many electrons, but look at, they're going to share their 2, so then it ends up filling their outer shell. When you have a single, and this is more information than you need to know, but when you have a single orbital, then you would fill it by just having 2. So this is now full and stable. This oxygen is now full and stable because it has 8 electrons in its outer shell, and this also is full and stable. This is a covalent bond. It's when it's sharing. Here they are sharing. Sharing is caring. Covalent bond, you can go ahead and say it out loud. Finally, chemical reactions. We are going to talk, you do need to know reactants and products. This is actually on the final test here. So the reactants are what's going into the equation. So in this case, the SO2 and the O2 are the reactants. They're going to react together and they're going to form the product, the end product. You can think of it like that. So these are, the products are what's produced from the reaction. So this is a chemical reaction. This is a chemical equation showing a chemical reaction. These are the reactants going in, the products coming out. And that is, oh no, we are continuing this. I forgot. So we're going to go into section 2-2 in your book. This is still segment 1. Vocabulary flashcard opportunities will be the words polar, hydrogen bond, acid base, and buffer. As a refresher, what you've learned before, acids and bases. Acids on the periodic table, here's your numbers for the pH down here. As you go from less than 7 all the way to 0, we're looking at the acid side. Acids, more acidic as you go this direction. So the lower the number, the more acidic it is. Because it's more acidic, what's making it more acidic is this hydrogen ion. These, which you can barely tell what they are, these are negative exponents. So you're going to get a lower and lower number as you go this direction for the hydrogen ion. So there's more hydrogen ion on this side of the periodic table. Or pH scale, sorry. pH scale. And then the hydroxide, the OH negative ion, is in higher concentration as we go on to the basic side or alkaline side. Alkaline is another word for base. So anyways, with a pH less than 7, that is your lower numbers. That's more acidic. With a pH that's greater than 7, you have more basic or alkaline solutions. Neutral solutions are those that have equal amounts of hydrogen ion and hydroxide ion. If you think about it, H plus is your hydrogen, hydroxide is OH negative. When you put those two together, what do you get? Water, H2O, 2 H's and an O. That is a neutral pH of 7. And there are other things, so that's why we have pure water here as a neutral 7. Milk, blood, those are all very, very close to a neutral pH. Any solution out there is going to have some kind of pH value. A buffer is a vocabulary word that offers up something that helps prevent sudden pH changes. So what a buffer will do is it returns, a chemical reacts and accepts hydrogen ions, for example, or hydroxide ions, picks them up and returns the solution to a normal neutral range. So a buffer, for example, like acid rain, we're learning in earth science, acid rain is going to have what kind of pH value? Hopefully you said a low value, you know, a pH of 5, something like that. And you can add a natural buffer like limestone, and it will react with that acid rain and bring it back to a neutral pH. So acid base, neutral, and buffer. Polar bonds, you learned about ionic and covalent. Polar bonds are something that are just a little bit different. What do we have here in this example? We have 2 H's and an O, H2O, which is water. When you have water, these H's and their extra protons, they have a slightly positive charge here, and then here they have a slightly negative charge from this oxygen. Even though the whole molecule is neutral, and you learned that in your reading, it is not equally shared. Those electrons are not equally shared. It's a covalent bond, they are sharing, but they're not equally sharing. More of the electrons are pulled in this direction, so therefore it has a slightly more negative side right here, and here is a slightly positive side. Oxygen has a stronger pull on those electrons. So therefore you have, even though this is neutral altogether, you have a molecule that is slightly negative and slightly positive. Well, now you have an attraction. Whenever you have that positive and negative, you have an attraction going on. So think of water, you know, being attracted, water molecules being attracted to each other. I'll show you here. Like a hydrogen bond. So here we have another set of water molecules. There's one, there's another. These are water. The attraction between the positive and the negative sides, the slightly positive side over here is slightly negative because oxygen is pulling so hard on those electrons. It has a slightly negative side on the oxygen end. They will attract. So water molecule, this is called hydrogen bonding. And it's the bond between the positive hydrogen and the negative oxygen. And these are water molecules. We see hydrogen bonding happening. This is why you can put a bunch of drops of water on a penny and it can bubble over without spilling. This is because of that kind of a bond. And that, my friends, is it.